Hi, welcome back to the channel. So let's continue looking at triple integrals in Cartesian coordinates. Okay, so we are still looking at these uh, these interesting questions here. Okay, so we have looked at question one in the previous video. You can check out the link in the description. So let's get to look at question 2, 3, 4, and 5. But of course, it appears I have to look at each of the questions in a separate, each of them in a separate video. Okay. So looking at question 2, it says write six different triple integrals for the volume of the tetrahedron cut from the um, first octant by this plane here. Then we have to evaluate each of the six integrals to check if we'll get the same value. Of course, if I try to do each of the six integrals, evaluating them, that will take a lot of time, but we'll see how best we can approach this so that you can manage to come up with the others by yourself. So we are given 6x plus 3y plus 2z is equals to 6. That's if I'm not mistaken. Okay, yeah, it's the same. So we're talking about a tetrahedron in the first quadrant. So let's just go ahead and sketch this so that it gives us a picture of what we are really dealing with. Okay, so this is what we have. I'm just trying to move it a bit this side. Something like that. Okay, so this one right here is of course our x-axis, that's our y-axis, and this is our z-axis. So now let me try to look at the coordinates in each of them. Okay, so what I do is that I'm trying to find the coordinate of the tetrahedron in the x-axis. So what do? I'm going to set y and z to be equals to 0. So if I set y and z to be equals to 0, meaning I'm only looking at the x-axis. Okay, I'm not looking at a point in the x-axis. So if z and y are equals to 0, I'm just going to have like 6x is equals to 6. Make 6 the sub of the formula. 6 is going to be equals to 1. So this tells me to say I have a point maybe somewhere here. We have to say that's a 1. Okay, so that could be like 1 comma 0 comma 0, like that. So let's look at another point maybe in the y-axis, meaning x and z are equals to 0. So it will be like 3y is equals to 6, meaning y will be equals to 2. So it's like we have a point right here that can be like 0 comma 0 comma 2 comma 0. Then we look at the point in the z-axis, meaning x and y equals to 0. So that'd be like 2z is equals to that, meaning z is equals to 3. So we have a point right here. Okay, that's um that's going to be a 3, so it can be written as 0 comma 0 comma 3, like that. So you can go ahead and try to connect these because you're only focusing on the first octant. So you can say you're moving from this point to that one, from that one to down here. Then actually let me use a different color. So from this one to this one here, and from that one to that one, this one to this one, like that. Interesting. Okay, so let me write down some orders of integration so that they guide me on which one I'm going to start with. So of course, I'll start with dz, dy, dx, then followed by dz, dx, dy. Then we are going to have these. What else can I have? I'm going to have dy, dz, dx. I can also have dy, dx, dz. The fifth one is dx, dz, dy. The last one is dx, dy, dz. Okay, so now looking at the first one, so I might just maybe explain two or three, but the same way that I'm going to explain them, the same steps, you can use them to come up with the other one. And if you have watched the previous video, I've tried to simplify the idea of the first steps that you take when you're coming up with limits of integration. So what you do is that for this one, let's say we're talking about the first one, just focus on dy dx, meaning you are focusing on the xy plane. And when you're focusing only on the xy plane, that's when those are only planes that you're able to see, and those, it simply means z is equals to 0. You kind of like ignore the z. So what this means is that when you view it from the top, of course, keeping in mind to say this is our x-axis and that is our y-axis. When you view it from the top, what you'll be able to see is something of this kind. Okay, so keep in mind to say what you have here is a 1. Okay, and what you have here is a what? Is a 2. So remember, I'm only focusing on, first of all, the dy dx, meaning only focus on the x y plane. Okay, so if you look at the outside most, the outside most is dx. Simply means there, this is supposed to give me a some single value, to say so, not really an expression that has x, y, or z in it. So it simply means I'm just supposed to have value. So what this tells me is that for the outside most, I'm supposed to move from 0. Why am I moving from 0? The lowest I can have is what? Is 0 here. That's my starting point. Then I'm coming in this direction. And the furthest I can go in the x-axis is what? Is a 1. Okay, is a 1. Then the inside, the more like the middle part. So we are moving from 0 quite alright. Then we are going in this direction. Then the furthest you can go, the mistake that you can make here is thinking to say you are going to 2. You're not going to 2. The furthest you can go is limited by this line here. So the question is, what is the equation of that line? The equation of that line is this one here, equals to 6 when z is equals to 0. Okay, so here it simply means we're just supposed to put z to be equals to 0. Then we make since we are talking about y, we are going to have to make y the subject of the formula. Okay, um, let's see how that's going to end up to be. Sorry about that noise on the background. um, so this would be like 6x plus 3y is equals to 6. Okay, we are saying our z is equals to 0 because we're only looking at the xy plane. So here, since you're talking about the y, meaning y has to be the subject of the formula. Okay, so meaning this would be like 3y is equals to 6 minus 6x. So we're going to have like y is equals to 2 minus 2x. So here you have like 2 minus 2x. That's how you come up with that point. It's as easy and interesting as that. Okay, let me just use red ink. So you say 2 minus 3x. Is it 2 minus 3x or 2 minus 2x? It's actually 2 minus 2x. Let me see again. We have 6x plus 3y is equals to 6. Then this is going to be 3y is equals to 6 minus 6x. So y will be equals to 2 minus, yeah, this 2 minus 2x. 2 minus 2x. Like that. Okay. Then let's look at the inside most. So for the inside most, we are starting from the plane. Like this plane is our like the starting point. So it's like this one right here. Then you are going on top like this. So you observe to say the lowest you can have is a 0. The furthest you can have is the equation of this one right here. This same tetrahedron in the first octant. So the equation of that in terms of z is simply this one. You just have to make z the subject of the formula. When you make z the subject of the formula, you're going to end up with something like 3 minus 3y over 2 minus 3x. Then here you're going to have dz dy dx. Okay, so I've come up with this one. Let's go ahead and determine that one. So it's quite evident to say, let me do this. For the inside part, since this is still be like dz, then here we just change to dx, then dy. This will still be from 0 to 3 minus 3y over 2 minus 3x. Then let's go ahead and determine this. So for the outside most, in this case, we are saying it's a what? It's a y. So we are saying, okay, we are starting from 0. The furthest we can go in the y is what? Is 2, starting from 0. So you stay from 0 to 2. Then for the x, which is the middle part, we are saying, okay, we start from 0, which is this one, then we'll come in this direction. but the furthest we can go is simply this line here, and we have said this line is this equation without z, so it's like 6x plus 3y is equals to 6. But since you're talking about x, make x a subject to the formula, so this will be like 6x is equals to 6 minus 3y. What will this be? X will be equals to 1 minus y over 2, so it will be 1 minus y over 2, like that. Okay, so that's basically how we come up with those. So should I look at the others? Let me see which one I can pick. So this is what we have. So let's go ahead and from which side can I view it now? I feel like these two these two explanations, they have highlighted the key points that you really needed. Okay, let me look at the last part. Okay, let me view it from the xz, meaning if you look at this one here, it's like any of these two. You're looking at dz dx or dx dz. So what happens is that this is what you're going to see. It's going to be something like this. Wait a minute. It's going to be something like that. Okay, then you also have something like that. So keep in mind, this is your z-axis and this is your x-axis. I'm just viewing it from this direction. Okay, so this is a 3 quite to right, and that's a 1, and that's a 0, like that. Then this line here is an equation where y is 0, so meaning it's supposed to be like 6x plus 2z is equals to 6, like that. Okay, that is what this line is. So first of all, if I were to look at which one am I going to look at? Let me look at dx dz, meaning the outside most in terms of z is supposed to be okay, let me see if I can erase these two. I hope you have copied them. In terms of z, the furthest I can go, since I just want it to be a point, like it's from 0 to what? To 3. So it's like it's going to be from 0 to 3, so that I have dz outside. I'm looking at this one here. Okay, then the middle, I'm looking at the x, so I'll move from 0 going in this direction. The furthest I can go is up to this line, so in that line, just make x the subject of the formula, so it will be like 6x will be equals to 6 minus 2z. So this will be like x will be equals to 1 minus z over 3, so it will be 1 minus z over 3. Okay, then the inside most, which is our y, will start from 0. So keep in mind to say this one here is just more like that's our base, so now we'll be going in this direction. So you observe to say our base, of course, is starting from 0. It's like at this point we have a 0. Okay, because that's where y is equals to 0, that's why I'm putting 0. Then the furthest we can go is up to the tetrahedron itself, the equation of the tetrahedron, but we just have to make y the subject of the formula. So here's what we have. So we have this so we have that equation there, so you just have to make y the sub of the formula, so that'd be like 3y is equals to 6 minus 2z minus 6x. So divide both sides by 3, that would be y will be equals to 2 minus 2z over 3 minus 2x. Is it? Yeah, it is. So we say 2 minus 2z over 3 minus 2x. This will be dy dx dz, which is that one. So it's just about, look at the end point, the two end points, that's where you are viewing it from, then you continue like that. Okay, so having done that, I'll leave the other three for you to find, which is this one, and that one. Then you try to evaluate and see if you're going to come up with the for the same thing. Like, I'm also going to leave the link of my contact, my WhatsApp contact on in the description, so that you'll be able to get in touch with me in case you need some consultation or something. Yeah, so let's go ahead and evaluate one of them and see what we are going to end up with. Okay, let me actually evaluate this same one that I have found and see. Just place it up there. Okay, so let's go ahead and do the integration. We are first of all integrating with respect to y. So this is moving from 0 to 3, then from 0 to 1 minus z over 3. So integrate with respect to y, you get a y. Okay, so that's like a y. You're moving from 0 to this one here, which is your 2 minus 2z over 3 minus 2x. Then you have your dx dz now. Okay, so what this is going to evaluate to is going to be we say from 0 to 3, from 0 to 1 minus z, is it z? Yeah, it's z over 3. Then here the lower limit is going to give you 0, so the upper limit is going to be 2 minus 2z over 3 minus 2x. This integrate with respect to x, like that. So let's go ahead and do the integration from 0 to 3. Integrate with respect to x. This is going to be 2x. Okay, 2x minus 2z over 3x minus, this is supposed to be, this is going to be actually x squared, because you'll be saying 2x 1 plus 1 divided by 1 plus 1. That's like 2x squared divided by 2. That's just going to be x squared. That's how I've come up with that one. So evaluating from 0 to 1 minus z over 3. Then we have your dz there. So you observe to say the lower limit is just going to give us 0. So just evaluate for the upper limit. So here we're going to say we have 2 multiplied by 1 minus z over 3. Z over 3 minus 2z over 3, open bracket, you have 1 minus z over 3 minus 1 minus z over 3 squared. Then you put dz there like that. So let's do the expansion. From 0 to 3, here I think I can have 2 minus 2z over 3. Then here I'll say minus 2z over 3 plus, that's going to be 2z squared over 9. Then here say minus, let's say minus 1 plus, oh no, I'm supposed to expand that part. Okay, let me expand this before I do the subtraction. So it will be minus 1 minus z squared over 9. Then the other one, that is going to be minus 2z over 3, if I'm not mistaken, because it's like minus z over 3 minus z over 3, that's like 3, you get minus 2z over 3. Yeah, that's that. So if you distribute the negative, this is going to be 1, and actually this is going to be a plus, I think. Yeah, it's a plus. So that would be minus 1 minus z squared over 9. Then here we're going to have plus 2z over 3. So you have dz there like that. Okay, this appears to be a lot of stuff to do, but we'll eventually find the answer anyway. So this, okay, so I observe to say that and that can cancel out. Then this I can subtract. Let me just try to reduce it. So this is going to be 1 minus 2z over 3. Then you also have this one and that one. Uh, that's actually going to give you plus z squared over 9, because you'll be able to do the subtraction there. I'm hoping I've done the correct thing. There are too much to do anyway. Okay, so let's go ahead and do the integration of the final part. So this is going to be z minus, this will be z minus, this will be, z squared over 3 plus, this will be z to the third over 27, moving from 0 to 3. Yeah, so what I've done here is it's like 2 over 3 z. So I have like 1 plus 1 the same as 1 plus 1, so this and that can cancel out. That's why I've just ended up with that. Then I believe you know where the other one has come from. So the lower limit to give us a 0. Then this one will say 3 minus, then you have 3 squared over 3, which is actually a 3. We have a 3 here. Then plus, if you put a 3 here, what is that going to be? So 3 to the power 3 is 27. 3 times 3 is 9, times 3 is 27, so that's a 1. So 3 minus 3 is a 0, then you get a 1. So the answer is a 1. Wait, we're looking for 1. That's too basic. Okay, I was thinking it was going to be something that's a bit some a big value. All this work just looking for 1. Anyway, interesting. So that's all in this video. Thank you very much for watching. I'll catch you in the next one.